Good evening, students. So you guys can let me know if there are any doubts. So is there any topic or any chapter that is not clear from any of the chapters where you're not able to solve problems? Can someone tell me?
No doubts.
Okay, then in today's class we'll do some problems from this book itself. So I want you all to try them. Okay. I'm only going to give you an outline. I want you all to speak. So first problem, how to do this? Whether it is right or wrong, try out the formula and tell me what it is. A 100 ohm resistor is connected to a 220 volt and 50 hertz AC supply. What is the RMS value of the current in the circuit? How to solve this?
Yes, V by R, right?
Okay. I is V by R. But what is the value of V we need to take into consideration?
220.
So 220 divided by R is
100.
So it will be 2.2 ampere. Right. What is the net power consumed over a full cycle?
V square by R.
So power is equal to V square divided by R. 220 square divided by 100. So 48400 divided by 100. It will be 484 watt. Suppose in this problem, instead of giving you a resistor, had they told it is capacitive reactance which is 100, then how you find the power in the AC circuit, power in the full cycle? Then what is the power you will use? Average power is equal to VRMS into IRMS into cos phi. Do you guys remember this formula? Right. So we need to use this formula to solve it. So be careful whenever they ask you. 7.2. The peak voltage of an AC supply is 300 volt. What is its RMS value?
V0 divided by root 2.
Sorry? VRMS is equal to?
V0 divided by root 2.
Correct. 300 divided by root 2. Or 0.707 times 300. If you'll get that value. So the RMS value of current in the AC circuit is 10 ampere. What is its peak current?
We should just multiply by it.
So I0 will be root 2 into 10. That will be 14.14 ampere. Correct? Next. 7.3. A 44 millihenry inductor is connected to a 220 volt and 50 hertz AC supply. Determine the RMS value of the current in the circuit. L is equal to 44 millihenry. V is equal to 220 volt. Frequency is equal to 50 hertz. Determine the RMS value of the current in the circuit.
First, you should find angular frequency.
So IRMS is equal to VRMS divided by XL. So XL will be equal to omega into L. Omega is 2 pi F into L. Substituting all these values and solving, you will get the value of IRMS. Okay. Shall we move on to the next one?
Yes.
So how to do the next one? A 60 microfarad capacitor is connected to a 110 volt and 60 hertz AC supply. Determine the RMS value of current. So IRMS is equal to VRMS divided by XC. So XC will be equal to 1 by omega into CF. So take all the values and substitute it there. This 110 volt is the RMS value. Frequency is 60 hertz. By substituting, you will get the required answer. Okay. 7.5. In exercises 7.3 and 7.4, what is the net power absorbed by each circuit over a complete cycle? Explain your answer. What is the answer?
The EI
It is 0. Why? Because the formula is ERMS into IRMS into cos phi, right? Where phi represents the phase difference between the voltage and the current.
That's
So when you talk
90.
for a resistor and for a capacitor inductor, phi is equal to pi by 2. If you substitute it here, answer will be 0. Okay, that kind of a circuit which does not consume any current is called as wattless current. Okay. Next. Try the next one. Obtain the resonant frequency omega r of a series LCR circuit with L is equal to 2 Henry, C is equal to 32 microfarad, R is equal to 10 ohm. How to do? So what is the formula for omega r? Omega r is equal to
1 by root x.
1 by root LC. Very good. 1 by root of L is how much? 2 into C is
32 microfarad. So 32 into 10 to the
32
power
into 10 power minus 6. Very good. Okay. So you can find the value from here. Those many radian per second will be the answer. They're asking about the Q factor also. Q is equal to 1 by R into root of L divided by C. Okay, substitute that, you will get the answer. Okay. Next. $7.7. So next one is, there is a charged 30 microfarad capacitor which is connected to a 27 millihenry inductor. What is the angular frequency of the oscillations? Omega is equal to 1 by root of L into P. L is
27.
27 into 10 power minus 3 into capacitance is 30 into 10 power minus 6. Okay. So that will give you the answer. Okay, next. Suppose the initial charge on the capacitor in XI 7.7 is 6 millicoulomb. What is the total energy stored in the circuit initially? What is the total energy at the time later? So total energy stored initially is half Q square by C. So Q is 6 into 10 power minus 3 the whole square divided by 2 into C is how much?
30 into 10 to the power minus 6.
Very good. 30 into 10 power minus 6. So 10 power minus 6, 10 power minus 6 gone. So you will have 36 divided by 2 into 30. This will go 6 times, that will go 5 times. So 0.6 joule will be the total energy. What is going to be the energy at later time? It will be, what will be the energy at the later time then? It will still be the same by because the total energy is always conserved. Right? So it is going to be the same. Next. $7.9. A series LCR circuit with R is equal to 20 ohm, L is equal to 1.5 Henry, and C is equal to 35 microfarad is connected to a variable frequency of 200 volt AC supply. When the frequency of the supply equals the natural frequency of the circuit, what is the average power transfer to circuit in one complete cycle? So what do you mean by when the natural frequency equals, when the frequency of the supply equals to the natural frequency? What are they trying to say? So wherever you see this kind of a statement, it means it is a condition of resonance. Okay. So what will be the answer? When the frequency under resonance condition, what is the average power transfer to the circuit in one complete cycle? So power is equal to V square divided by R. That's it. V is how much? We know that in the condition of resonance, a series LCR circuit behaves like a purely resistive circuit. So V is 200. So 200 square divided by R is 20. So it will be 40,000 divided by 20. Cancel it. It will be 2000 watt. Watt, or it can be 2 kilowatt also. Okay. Next. Seven point 10. A radio can tune over the frequency range of a portion of megawatt broadcast band, which is between 8,000 kilohertz to 12,000 kilohertz. If an LC circuit has an effective index of 200 micro Henry, what must be the range of its variable capacitor? It's very simple. So omega is equal to 1 by root LC. Okay. So omega is nothing. I can write as F is equal to 1 by 2 pi root FLC. So F lowest is 800 kilohertz. So when I write 800 into 10 power 3 is equal to 1 by 2 pi into square root of, what is the value of L, guys? L is fixed. 200 into 10 power minus 6 into C will be maximum. Why did I write C as maximum? Because when frequency is least, when the numerator is least, denominator has to be maximum. Right? So from this, find the value of C max. Similarly, frequency is high. Then 1 by 2 pi into root of L into C will be minimum. So what will this value be? It will be 1200 into 10 power 3 is equal to 1 by 2 pi into root of L is 200 into 10 power minus 6 into C minimum. So find the value of minimum value of C. That will give you the range. So C minimum is the least value, C maximum is the maximum value. That is what they meant by the range of its variable capacitor. Am I clear with this problem? Yes or no?
Yes.
Okay. Last problem. So figure 7.21 shows a series LCR circuit connected to a variable frequency of 230 volt source. L is 5 Henry and C is equal to 80 microfarad, R is equal to 40 ohm. Determine the source frequency which drives the circuit in resonance. So what is the frequency which drives the circuit in resonance? Means resonance frequency is equal to 1 by 2 pi root of L into C. You know the value of L, you know the value of C, take it and substitute it here, you will get the resonance frequency. Next, obtain the impedance of the circuit and amplitude of the circuit at resonating frequency. So what will be the impedance of a series LCR circuit under resonance condition? Z will be equal to, I told you just now, no? Z will be equal to R. Means answer is 40 ohm. So impedance is 40 ohm. Third, determine the RMS potential drops across the three elements of the circuit. So RMS potential drop is nothing but VR is equal to I into R. VL is equal to I into XL and VC is equal to I into XC. Okay. So to find the value of I, since everything is happening under the resonance condition, so I will be equal to V RMS divided by R. Okay. Find the value of I, take it and substitute it in each equation. That will give you the value of VL. Okay. So with this, the exercise problems are over. Additional exercise we will not solve. If you guys want to practice more, you can try it out. But there are certain concepts which should not be available in your textbook to solve additional exercises. Okay. So that's it from this problem, guys. Since you guys told there are no doubts, we can wind it up. I'll keep giving you assignments. You keep working on it. That's it.
Sir, and the test schedule says that we have test on Saturday, but the date is 13th. So it's Friday or Saturday.
It will be Saturday then.
But Saturday we have max test also.
There will be no clash. No, 1 minute wait.
Sir, the test schedule it says that we have a test on 13th, but the date given is Saturday.
See, are you checking the updated schedule?
Yes, sir.
Yes, schedule also. Wait. Yeah, 12th physics is on 14th.
Oh, sorry, sir. I was checking the old one.
We already sent an updated schedule. So, for 12th physics, that is 14/8 is magnetism and its matter test. Okay, which is Saturday. Seriya? And math test is on 15/8, which is Sunday, which has applications of derivatives.
Okay. Okay.
Okay. Just go and check the latest messages. Okay.
Okay.
Yeah, that's it from my side. That's it. Since you guys told no.
Sir, do we have to submit a test paper in the institute, sir?
Yeah, you have to do it.
When should we do, sir?
See, generally after the test, you ensure you give it on a Monday.
Okay.
Okay. So there are two things. One is once you complete the test, the paper has to be uploaded in the app. And second is once you upload it in the app, the original copy of the paper should be submitted in the institute within 1 or 2 days.
Okay, sir. Thank you.
Okay. So unless you are from other city or something, you have to submit it. Okay. That's it, guys. We can wind up. Okay. I'll see you all. I'll inform about the subsequent classes.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.